Hello and welcome to GER Mathematics and Statistics lessons. Today I'm going to be talking about real numbers. And what about real numbers am I going to be discussing? In this video particularly, I'm going to focus on natural numbers. Now, before I begin, please smash a like on this video. Tell a friend about this video. Tell a friend about our channel. Thank you for your subscription so far. Thank you for how well you have helped this channel to grow in terms of your likes, your shares of our videos, your views to our videos, your comments to our videos. We are very grateful from GER Hub. That being said, now let's begin. So, real numbers are better understood if you understand smaller number systems that make up what we call real numbers. So in this video, our focus will be on discussing natural numbers. Okay? So I'm going to tell you this one thing so that we don't keep you in suspense. Real numbers are larger. They are a larger system of numbers, okay, that contains smaller systems. And for you to really get a good grasp of real numbers, it is important you know the smaller systems that make up the real number system, okay? So I'm not going to start with telling you about real numbers, but I'm rather going to tell you about the smaller system of numbers that make up the real numbers. So I'm going to be taking them in a series, one after the other, beginning with this particular series containing natural numbers. So let us start with natural numbers. Now, what I'm going to say also is this. For each number system we discuss, I'm going to tell you the symbol that denotes that number system and the kind of numbers you find in that system. So let us start. Natural numbers are positive whole numbers. So that is my first statement. Natural numbers are positive whole numbers. That's statement number one. Now, why are they called natural numbers? They are called natural numbers because they are used for counting and arrangement by order. Okay, so two things we basically use natural numbers for is for counting and for ordering, okay? Placing order in a particular set. And this second statement gives rise to two things I want to tell you. So if a number is a natural number, then that number is either ordinal or the number is cardinal. Now, cardinal in the sense that they are used for counting. So numbers like 1, 2, 3, and so on are numbers we use for counting. So if you want to count, you use such numbers as 1, 2, 3, 4, 5, 6, 7, up to as large as you can. Now, on the other hand, natural numbers can also be used for creating order in a system. And for you to create order in a system, it means there should be some sort of arrangement. So, in that sense, we have numbers like first, second, third, fourth, and so on. Numbers that are used to show position of items in a collection. Okay? So, what should you also know about natural numbers? They are used for counting and arrangement by order. So when they are used for counting, they are called cardinal numbers. When they are used for putting arrangement in a system in terms of order, they are called ordinal numbers. Now, what else should we know about natural numbers, students? What we should know about natural numbers are, number one, natural numbers could be represented with any of the following symbols. So you could use a double stroke N to represent natural numbers. That is, this type of N can be used to represent natural numbers. And if you don't want to use this type of N to represent natural numbers, then there is another symbol we call Aleph. So Aleph is another symbol that is used to represent natural numbers. So out of these two, which one is more popular in textbooks and online sources? This one is more popular, although you can also use Aleph to represent natural numbers. Okay, so you get my point straight. Number one, natural numbers are positive whole numbers. Number two, they are used for counting and arrangement by what? Order. So the kind of numbers we use for our day-to-day transactions are natural numbers. Most times we use natural numbers in the marketplace. We use natural numbers in our offices. We use natural numbers in our churches, our religious houses, or our mosque. We use natural numbers wherever we find ourselves to count. So they can be used for counting and they can be used for putting arrangement in a system. For instance, in a class of 50 students, after an exam, you will be grading those students and placing them by position in terms of who came first, who emerged second, who came third, who came last. So you can also use natural numbers to create order in a system. And in that sense, you use first, second, third, fourth, fifth, and so on, okay? Now, the third thing I want you to know in this video about natural numbers is that natural numbers can be represented with either of these symbols. This one, the double stroke N or Aleph, okay? Now, the next thing I want you to know about natural numbers is that there is an ambiguity. There is this non-clarity as to what natural numbers should contain, and that brings me to the number 0. Okay, there is a number we call 0. You are very familiar with this, the number 0. Now, the number 0 was introduced or used by the Macedonians. So it was popularly used in ancient times by those group of people we call the Macedonians, okay? The Macedonians probably are the recent or modern day Indians or so. That may not be correct, but the 0 was actually used by the Macedonians, okay? In this day and time, I believe that the Macedonians may be the ones you actually regard as Indians or Asians, as the case may be. Now, what I'm trying to emphasize is this. The 0 is actually one number that is creating ambiguity or non-clarity among mathematics, the mathematical world. Now, what it means is this. There is a group of mathematicians that believe, that 0 should be a natural number. And there is another group that believe that 0 should not be a natural number. So, if we look at it critically, you will discover that natural numbers should be from 1, 2, 3, down to what we call positive infinity. So, this is what it should be. But because some group of mathematicians believe that 0 should be a natural number, in that case, natural numbers, for those who believe that 0 should be a natural number, they use this symbol or what is called Aleph null. So if this symbol is called Aleph, those group of mathematicians who believe that 0 should be a natural number actually put 0 as a subscript to this symbol that represents natural numbers, or Aleph that also represents natural numbers. And in that case, they write their natural number system as beginning from 0, going through 1, 2, 3, down to positive infinity. But there is another group of mathematicians that believe that natural numbers should not begin from 0, and that group actually write their own as this, and they call it n subscript 1, which is also written as Aleph 1. So Aleph 1 or n subscript 1 is the natural number system that begins with 1. That is, it excludes 0. Okay? That's another thing I want you to know about the natural numbers. That there are two types of natural numbers based on how mathematicians see natural numbers. So some mathematicians see natural numbers as a system of positive whole numbers that should include 0. And those who believe that natural numbers should include 0 actually begin it from 0, and they use the symbol n subscript 0 or Aleph null to represent natural number system. For those who believe that natural number system should exclude 0, they actually write theirs as this, n subscript 1 or Aleph 1, meaning that the natural number system excludes 0. Now, that is another thing I want you to know about the natural numbers. Now, the next thing I want you to know about natural numbers is this. Now, natural numbers have their properties, okay? So let us look at what properties of natural numbers exist. So we are going to look at them this way. Natural numbers, the set of all natural numbers or the natural number system is closed. So n is closed with respect to, WRT means with respect to. So n is closed with respect to addition and multiplication. What does that mean? Now, a non-empty set is said to be closed with respect to a binary operation if what I want to show you happens. Now, when is n closed with respect to addition and multiplication? And again, why is n closed with respect to addition and multiplication? So, if you can select any two elements from a non-empty set, in this case n, And it so happens that a combination using any of these operations on n gives you a result in n, then n is said to be closed. Meaning that if you select A and B from n, such that A plus B gives you a member of n, then you say that n is closed. Why is n closed? Take note, it is because any two elements you select from n and use addition on those two elements will give you a result that is also in n. Let us look at it. If you take 2 and 3 that are natural numbers as two random elements you select from the natural number system, take note, 2 plus 3 will give you a result in n. And 2 plus 3, take note, is 5. And 5 is a member of n. For that reason, we say n is closed with respect to addition. If you also look at it again, pick a number at random or pick two numbers at random, 7 and 8, for instance, that are numbers in the natural number system. You will notice again that 7 plus 8 will give you a number that is in n. What is 7 plus 8? It is 15, and 15 is a natural number. So when it happens that any two numbers you select at random gives you a result in that set, then that set is said to be closed with respect to the binary operation you used on the two elements. Okay? Now, again, we have just said that n is closed with respect to addition, and I've just given you an example of that. What about the second one? N is closed with respect to multiplication. Now let us see. If n is closed with respect to multiplication, it means that any two elements you select from n, when they multiply, will give you a result that is in n. Now if you look at it again, 2 and 3 are members of n. 2 times 3 will give you a member of n. What is 2 times 3? 2 times 3 is 6, and 6 is a member of n. If you select any two again, such as 5 and 8, if you select 5 and 8 that are members of n, and you multiply them, 5 times 8, you get a member of n. What is 5 times 8? 5 times 8 is 40, and 40 is a member of n. So when you select any two elements at all from n and multiply both of them, it will give you a result that is a member of n. For that reason, we say that n is also closed with respect to multiplication. Okay? Now, that brings me to the next property. The next property of natural numbers I want to show you, whereas addition and multiplication are whereas n is closed with respect to addition and multiplication. However, n is not closed with respect to subtraction and division. N is not closed with respect to subtraction and division. Why? If you select A, B that are any two elements that are members of n, and take A minus B, not all the time will you have A minus B as a member of n. Let us see. If you select, for instance, 2 and 3 that we selected earlier that are members of n, notice that 2 minus 3 is not a member of n. Why? 2 minus 3 will give you minus 1. And minus 1 is not a member of n. Remember, why is minus 1 not a member of n? Minus 1 is a negative number. And negative whole numbers are not members of n, because n is the set of all positive whole numbers. Okay? Positive whole numbers are the only type of numbers found in n. So if you perform this on any two elements, if you use subtraction on any two elements you extract from n, you will notice that not all the time would you have the result as elements in n. For that reason, we say that n is not closed with respect to subtraction. Excuse me. So, what about division? Now, again, n is not closed with respect to division. Why is that so? If you take any two elements, A and B, that are members of n, notice that A divided by B may not be a member of n. It may not. But provided it may not be a member of n, what does it mean? It means that n is not closed with respect to division. Now, if you look at it again, pick any two elements such as 5 and 6. If you pick any two elements, 5 and 6, that are members of n, you will notice that 5 over 6, or 5 divided by 6, may not be a member of n. And in this case, it is certainly not a member of n. Okay? Because fractions are not members of n. They are not members of n, because we had earlier defined that n is the set of all positive whole numbers. So fractions are not members of the natural number system. So if you take two elements, say 5 and 6, that are members of n, and divide them one by another, you end up getting results that are not members of n. And for that reason, we say that n is not closed with respect to division. Now, A third property I want to show you about n is the property of commutativity. Now, when a binary operation is said to be commutative, so I want to state this property this way: addition and multiplication are commutative. They are commutative on n. Addition and multiplication are commutative on n. What does that mean? It means that if you select any two elements from n, a plus b will give you a member of b, or a plus b will give you a member of n. Tells you that it tells you that addition is commutative on n. Okay, especially when a plus b is equal to b plus a. Okay, so if you select any two elements from n such that the first plus the second gives you the second plus the first, then we say that addition is commutative on n. Now, if you look at it critically, you see that if you select 2 and 3 that are members of n, clearly 2 plus 3 will give you 5, and that 5 is the same thing. That 5 can be obtained by adding 3 first before 2, that is 3 plus 2. And that shows you that addition is commutative on n, because commutativity talks about adding, putting two things in one direction and getting the same result in the other direction. So if you add a and b together in this direction, that is putting a first before b, and you get the same result as putting b first before a, then we say that addition is commutative. Now, if you look at it again, another property here is that under commutativity tells you that a plus a and b, if they are selected from n, implies that a times b will be equal to b times a. So if a times b is equal to b times a when a and b are selected from n, then we say that multiplication is also what? Commutative on n. So if you look at it again, 2 times 3, 2 and 3 were selected from n. Notice that 2 times 3 is equal to 3 times 2. Okay? And the result is 6, which is a member of n. So when 2 multiplies 3 and the result is the same as 3 multiplying 2, then we say that multiplication is also commutative on n. That is the property of commutativity. Now, let us go to the next property. You will notice that whereas addition and multiplication are commutative on n, you will notice that subtraction and division are not commutative on n. So that property states that subtraction and division are not commutative. They are not commutative on n. And why is that so? It means that if you select any two elements, a and b, that are members of n, then a minus b is not equal to b minus a. Likewise, a divided by b is not equal to b divided by a. And when this happens, it means that subtraction is not commutative on n, and likewise division is not commutative on n, because the result in one direction is not the same as the result in the other direction. Let us look at an example to illustrate this. If I pick two elements, let's say 16 and 17, that are members of n. Why are they members of n? Clearly, 16 is a positive whole number, 17 is also a positive whole number. Now look at it critically. Is 16 minus 7 equal to 17 minus 16? No, they are not equal. So since 16 and 17, which were selected from n randomly, are not equal to 16 minus 17 being 17 minus 16, then we say that the result shows that n is not commutative with respect to subtraction. Note that 16 minus 17 will give you minus 1, but 17 minus 16 will give you 1, and 1 is not equal to minus 1. Now, if you look at it again, what about 16 divided by 17? 16 divided by 17 can be expressed as 16 all over 17, which is a proper fraction, and this is not equal to 17 divided by 16, which is an improper fraction. Okay, so these results are not the same. Now, what does that mean? When the result in one direction is not equal to the result in the other direction, it means that the binary operation you use to combine both of them in both directions is not commutative. So subtraction and division are not commutative on n. That is another property I want you to know. Now, take note again, there are other properties you can talk about with respect to the natural number system. The properties of associativity. The properties of associativity. Okay? the properties also of distributivity are other properties you can talk about, whether or not a binary operation defined on n is distributive or associative. Okay, so you investigate that. But let me tell you, if A, B, and C are members of n, we say that a binary operation defined on n is associative. For instance, let us see positive or addition. Is addition associative on n? For you to know whether addition is associative on n, then pick any 3 elements at random from n and see it this way. Is A plus in bracket B plus C equal to A plus B in bracket plus C? The answer is a big yes. So, because this is true for addition with respect to the natural number system, what do we say? We say that addition is associative. Addition is associative on n, the set of natural numbers. Okay, so if you pick 3 numbers 2, 4, and 7 that are members of n, notice what is happening. 2 plus 4 plus 7 with 4 plus 7 in bracket will give you 2 plus 11, which is the same thing as 2 plus 11 is 13. Okay, now on the other hand, is the result equal to 2 plus 4 in bracket plus 7? You will notice that the result 2 plus 4 gives 6, and 6 plus 7 gives you 13. So the results are the same. And what does that tell you? It tells you that addition is associative. So you investigate using what I have just told you, whether subtraction is associative on n, whether multiplication is associative on n. I can boldly tell you that multiplication is associative on n because A times in bracket B times C is equal to A times B in bracket times C. Okay, so this is true for the natural numbers. Please take note of that. Now, these are some of the properties on natural number system that I want you to know. There is also the property of distributivity. Okay, now if you take it this way for associativity, looking at it critically so that we don't leave any stone unturned. Now, if you look at this, you will notice that the same 2, 4, and 7, if you look at it, 2 times in bracket 4 times 7 is the same thing as 2 times 4 in bracket times 7. Why? 4 times 7 is 28. So 2 times 28 will give you 2 times 28 will give you 56. Okay? Now on the other hand, this is 2 times 4 giving you 8, and 8 times 7 is what you have. You notice that 8 times 7 will also give you 56, and that shows you that multiplication is associative on n, in natural numbers. So what have we established here? Another property to take note of is that multiplication and addition are associative on n. But I'm going to tell you for a fact that subtraction and division are not associative on n. So you take note of that. Subtraction and division are not associative on n. Now, there is the property also for natural numbers of distributivity. So, distributivity. Now, if you pick any 2 or any 3 elements from n, and you notice this about them, such that A times B plus C is equal to A times B plus A times C, then this property is called the property of distributivity. What it means is that the binary operation outside is distributive over the one inside. If this is true, then it means that multiplication distributes over addition on n. Okay, and that is truly true because 2, 3, and 6, if you select from n, would show you that 2 times in bracket 3 plus 6 is the same result as 2 times 3 plus 2 times 6. This is true, and that is because 3 plus 6 is 18, and 2 times 18 will give you 36. If you come over here, 2 times 3 is 6. 2 times 3 is 6 plus, what do you call it? Okay, this is 3 plus 6 giving you 9. I was actually doing 3 times 6, so sorry about that. So 3 plus 6 will give you 9, and 9 times 2 will give you 18. So that I have corrected. Now on the other hand, 2 times 3 will give you 6. Okay, and 2 times 6 will give you 12. If you look at it again, 6 plus 12 will give you 18. So you can clearly see that when this is true about a non-empty set, then we say that multiplication distributes over addition. Now, another property of the natural number system is that for any 3 elements you select from the natural number system, distributive property holds for multiplication over addition. But addition does not distribute over multiplication. So you take note. Whereas this is true, take note of the fact that A plus in bracket B times C is not equal to A plus B times A plus C. This is not true. So what it means is that addition does not distribute over multiplication for a natural number system. Okay? Now, there is the property of identity for a natural number system. There is the property of identity, and there is the property of inverse, the inverse element. So the question is, what is the identity element on n? The identity element, what is called the identity element? The identity element on n, the natural number system, is 0 with respect to addition. And the identity element on n, I'm going to explain this. The identity element on n is 1. 1 with respect to multiplication. Okay? So, why are those things so? You will notice that identity element, if you select A from n, if you select 2 elements, A and E, from n, such that A plus E is equal to E plus A, and the result gives you A, then E that combined with A in both directions to give A is said to be, then E is the identity element with respect to that binary operation, in this case, addition. Similarly, if A times E is equal to E times A and the result is A, then E is also the identity element. But this time around, it is the identity element. It is the identity element. It is the identity element with respect to, in this case, multiplication. So when we say that the identity element on n with respect to addition is 0, what do we mean? It means that 3 plus 0, if you take 3 and 0, obviously, that you can call members of n. This is even the reason why those mathematicians who believe that 0 is a natural number actually may be right, that 0 is a natural number. So that is because if you pick 0 and 3 from n, you will notice that the identity element is 0, because 0 plus 3 will give you the same result as 3. 3 plus 0 will give you the same result as 0 plus 3, which is 3. So if you add an element of a natural number system to 0, it will return that element, and that shows you that 0 is the identity element in n with respect to addition. Also, there is the identity element with respect to multiplication on the natural number system. And what is it? If you select 3 and 2 that are members of n, you will notice that there is an element 1 also in n, such that 3 times 1 will give you 1 times 3, and it will give you 3. Again, if you pick 2 times 1, it will give you 1 times 2, and it will give you 2. So, what is the identity element? It is that element that will multiply with any other element in that set to return that same element. Or it is that element in the set that will add to any other element in that set to return that same element. That being said, thank you very much for watching our video on natural numbers, especially under the real number system. Thank you very much for watching. Please watch out for our video on the integer number system, still under real numbers, and I will see you in a bit. Thank you very much.